Okay, we're going to look at the limit as xy approaches 0, 0 of xy squared over x squared plus y to the fourth. And we are going to look at this by approaching from different directions. This will be the first path I'm going to take towards 0, 0, and that's along the line y equals 0. So what is the result if I approach along y equals 0? We replace all the y's with zeros. So I get the limit as x comma 0 approaches 0, 0 of what? Of x times 0 squared divided by x squared plus 0 to the fourth, which will be the limit as x approaches 0 of 0 over x squared, which is 0. So that's my first path. Now my next path is going to be along the line x equals 0. So what does that look like? Coming here, coming here. If I'm going along the line x equals 0, then I replace all the x's with 0. So going back to my original, it'll be the limit of 0 comma y approaches 0, 0. Replace all of the x's with zeros, so that's 0 y squared over 0 squared plus y to the fourth, which is the limit as y goes to 0 of 0 over y to the fourth, which equals y. Okay, so we've taken two paths and we've got the same result each time. Does that mean the limit exists? Does that mean the limit exists? The answer is no, no. I mean, let's try a third path. Is that enough? If I have three paths and they're the same, is that enough? Still, the answer is no. But this time I'm going to check along the line y equals x. So coming this way, along y equals x. So I'm going to replace maybe all of the y's with x. So looking at my original statement, we have the limit as x instead of y, x, because y equals x. Approaches 0, 0. X times, replace the y with x. X squared over x squared plus, replace the y with x. X to the fourth. Now I'm down to one variable. Limit as x approaches 0 of x cubed over x squared plus x to the fourth. And this can be solved with L'Hopital. Notice we have a 0 over 0 case. Plug in 0, 0 cubed, 0 squared plus 0 to the fourth, so L'Hopital is okay. So what do we get? We get the limit as x goes to 0, the derivative of the top, 3x squared, derivative of the bottom, 2x plus 4x cubed. Notice, still 0 over 0, so L'Hopital is okay again. So what is that going to be? Derivative of the top. Limit as x goes to 0. What do we get? Upstairs we get 6x. Downstairs I have 2 plus 12x squared. What do I get now? Upstairs 6 times 0 is 0. Downstairs 2 plus 12 times 0 squared. I get 0 over 2, which equals 0. I have used three paths, and I have found 0 each of those three times. Is that enough to conclude that the limit is 0? The answer is no, no. I want to go back and take a look at the spreadsheet just to convince ourselves that we see that it approaches 0 on each of those paths. So here we go. We have xy squared over x squared plus y to the fourth, 0 over 0, division by 0, not in the domain. Here's all the values where x is 0. Notice what shows up here. Those guys are all values. Here, notice all of the what's. Notice that what do we have here? We have all of the y values are 0, and here the x values are getting closer to 0. The result is always 0. And then finally, what do we have? We have x and y are the same. Now, what are these getting closer to and closer to? They're getting closer and closer to 0. So again, that indicates that each of these three paths is giving us the same result. But is that sufficient? Is that sufficient? Well, no, it's not. We're going to take a look at one more path, and if we can find a different result, a different limit, then we conclude that the limit doesn't exist. So again, these three paths, this way, and this way, all gave me 0, but that still is not sufficient to conclude that the limit is 0. So I've got one more path that I want to try. I'm going to look at the path x equals y squared. Now, does that approach 0, 0? What does x equal y squared look like? Comes in like this. So sure enough, it does. And let's take a look at our spreadsheet first to see if indeed we are going to get something that is a result other than 0. All right, so I've got y values approaching 0. And I want x to be y squared. So x equals y squared. So that's there, and we'll go ahead and we'll copy all of these. So those are the values I get there. Now let's go ahead and copy this down. And where do these numbers seem to be going? They seem to be going to 0.5. So if x equals y squared, the result seems to be 0.5, which is different from 0. So here we go. How do I do this? X equals y squared, fine. So wherever I see an x, I'm going to replace it with y squared. So I've got the limit y squared comma y approaches 0, 0 of what? X equals y squared. So we've got y squared times y squared over x squared, which would be y squared squared plus y to the fourth, which will give me what? Now this is indeed the same as the limit as y goes to 0. What do we have here? Y squared times y squared is y to the fourth. What do I have on the bottom? Y squared squared, y to the fourth plus y to the fourth. Interesting. Which is the limit as y goes to 0 of y to the fourth over 2y to the fourth, which is the limit as y goes to 0 of 1/2, which equals 1/2, which is different from 0. So what is my conclusion? The limit as xy approaches 0, 0 of xy squared over x squared plus y to the fourth does not exist.